assembly line balancing. So when demand in March was 125 scooters per week, it didn't make any sense to change anything in the assembly line. We had some imbalance in the activity times, but this is a little bit unfair to workers, but it doesn't hurt our capacity, our flow rate, because our capacity, 161 scooters a week, was still higher than the demand. So there was no need to improve anything, at least assuming the demand would remain 125 scooters per week. Now consider what happened in May. In May, the demand has increased to 200 scooters per week. And if demand is this high, now assuming capacity remains still 161, we are limited by capacity now, right? We should produce more scooters. We're trying to produce as much as possible, right, to match the demand, but the capacity is limiting us, and therefore our flow rate is now 161 scooters per week. Now process is capacity constraint, not demand constraint, as in March. Again, if you try to calculate the cycle time now, of course, right, inverting the flow rate will get us to 13 minutes per scooter, which was the activity time for the bottleneck. Now the sum of idle times is, right, cycle time minus activity time, cycle time minus activity time, cycle time minus activity time. A total here is just those 2 minutes here and 5 minutes here, 7 minutes per scooter. And if you calculate average labor utilization, it actually did increase. It's 82%. It's more than 63.5% before, when we were producing at the rate of 125 scooters per week. And also, if you recalculate cost of direct labor, right, these were the wages of workers divided by the flow rate of scooters per week, both of them dollars per week, and this is scooters per week, both of them per week. Now the cost of direct labor is 7.83 dollars per scooter. Notice this is less than $10 that we had before, right? Because now we produce, with the same labor cost, we produce more scooters. So the cost allocated to each scooter has decreased significantly, but it is still more than $6.40 if we used all the time of the workers, right? If all the time of the workers was used in a productive way, then this should be $6.40, as we calculated earlier. So can we do better? Well, yes, we can, because we can do something about the remaining idle time, the 7 minutes per scooter that is wasted due to the fact that there is imbalance in the activity times, right? So what we can do is we can balance the assembly line. We can do something to remove these discrepancies in activity times. But for that, we need to look at in more detail what these workers are doing, right? Before we just aggregated the tasks that they do, just we looked at 13 minutes, 11 minutes, and 8 minutes. Now we need to see what's hidden behind this. So if we do the actual detailed analysis, let's say we have a total of 26 tasks. This is a table, right? This is the first line is the first 13 tasks. The second line is the second 13 tasks, right? And we see that the total time is 1890 seconds. We can now try to reassign those tasks among the 3 stations, right, with 1 worker on each. Assume that we are going to assign them in such a way that we cannot change the order of those tasks. So they have to be done 1, 2, 3, 4, and so on. Certain number by the first worker, then certain number by the second worker, and certain number by a third worker. If we do tasks 110 by a first worker, 11 to 17 by the second, and the remaining tasks by the third, we, I think, get the best possible balance, which will give us, right, 623 seconds, 602 seconds, and 665. Notice this is all roughly between 10 and 11 minutes, slightly more than 11 minutes here, right? 5 seconds more. And so it gives us, right, in this case, the capacity of each could be calculated as 1 over this. Obviously, the bottleneck will be the one with the longest time. So the capacity of the assembly line will be 1 over 665 seconds per scooter. right? Again, the converting this to capacity per week gives us almost 190 scooters per week, right? So 189.5 scooters per week. If this is the capacity now after balancing the assembly line, right? After reassigning some activities from some tasks from one station to another, right? We have a better balance. Now the flow rate will be minimum capacity 89.5 and the demand is 200. It will be much closer to the demand. And now if we recalculate the average labor utilization, right? In this case, the productive time I calculated per week divided by the available time, it's 96.3%. And so it is the cost of direct labor. If we also recalculate it, we'll find out it's $6.65. There is still a little bit of idle time, but much less, right? Because the times of those stations are much closer to each other, and especially the largest of them has decreased, right? Notice, remember, the bottleneck station had 13 minutes per scooter. Now this one has just a little bit over 11 minutes per scooter. The bottleneck is now station 3, right? So graphically, we can see the balancing, right? Initially, these were the assignments, and you see the cycle time of the assembly line. The smallest we could have used was due to station 1 or step 1, right? In this case, station 1 having the largest total time of activities or tasks, right? And this, therefore, was the smallest cycle time. Now, after rebalancing, the line can be lowered, right? It cannot be smaller. We can not go below the mostly loaded station. So in this case, station 3 becomes the bottleneck, but that means, we can go down with the cycle time to almost 11 minutes, right? 11 minutes and 5 seconds. So a key point here is also important. This step, the assembly line balancing, was not necessary when demand was small. When our capacity was larger than the demand, we didn't need to balance the assembly line because just balancing it would just shift the idle time between the stations, right? Before we had a lot of idle time, right, due to this imbalance, but also remember the flow rate, the actual cycle time was much higher, right, because the demand was smaller. So we would just rebalance the idle time. This balancing before would only have the benefit of a more fair division of labor, right? But it wouldn't really improve our flow rate because we would still have to produce at the rate of demand. When the demand increased and the capacity became insufficient to match with the demand, this is when it became necessary to balance the assembly line in order to increase our flow rate, right? We increased it from, remember, 161, the capacity was increased from 161 to 189.5. And if the demand is 200, with this, we're able to satisfy much more of the demand than before.